Hello students, in this video I'll show you how to graph piecewise defined functions using your TI-84. I might need to split this video into 4 parts, that way I can show you how to find the intervals for the functions and then how to graph them using your graphing calculator. I will be graphing 2 functions. The first one will be f of x equals, for the interval where x is smaller or equal to 2, negative 2x plus 5, and the function x plus 1 for the interval x is greater than 2. I would like to review with you the difference between the less than or equal to and greater than or equal to. Please remember that these are the inclusive inequalities, and less than, strictly less than or strictly greater than are the exclusive inequalities. In other words, this one includes the point in the interval, and strictly less than or strictly greater than excludes the point or does not include. In your graph, in your number line, you might see the inclusive one as a filled point, as a continuous line, maybe a turning curve. For the exclusive, you will see an empty point. In your graphs, you might see an asymptote. And we always use exclusive when we're talking about the ending sides of your number line, like all the way to negative infinity or all the way to positive infinity. For the interval notation, inclusive is in the form of a bracket, and exclusive it's in the form of a parentheses. And we always use parentheses for when you're writing your interval ending at negative infinity or positive infinity. Now that I covered all of this, notice how my intervals are different, or separated by the number 2. You can create your number line. Remember, towards the left are my negative values, towards the right are my positive values, and I only have 2 intervals here, greater than 2 and less than or equal to 2. For less than or equal to 2, that or equal to 2 means it includes the 2. It stops at 2, and if you want to, you can put your filled point with that particular color. Greater than 2 means strictly greater, does not include the 2, and it starts right after 2. It does not touch this one, so it will be an empty point from the purple side. I'm not going to put it because we already filled it with the filled point, but just so you know, that 2 is included on the interval that it's less than or equal to 2. Which means this function, the first one, negative 2x plus 5, is defined on the interval from negative infinity to 2, inclusive on the 2. And the function x plus 1 will be defined on the interval from 2, exclusive, all the way to positive infinity. Now, if we want to use our graphing calculator, this is how we would input in our graphing calculator our values. We will have to write it as follows, with parentheses for the function, then another parentheses with the inequality or the interval in inequality form, plus to say and then the second function with the second interval, again with parentheses, separated with parentheses. Please make sure that you're including all the parentheses, and that if you have more than 2 piecewise defined functions, you include them all in the same line. Let me try to fit my calculator in the video. Here we go. I will go to y equals to graph my function, and I already inputted here. Let me type it in again. It was parentheses. Then remember we used the negative symbol for a sign. 2x plus 5. That's my first defined function. Then I follow it by the interval. X is less than or equal to 2. To insert any inequality symbols, you go to second math. Second, this button on the very top left corner, and math underneath alpha. You can choose whichever inequality you want by the number. I want less than or equal to 2, which is number 6. I can press number 6, or I can scroll down until I get to the inequality value that I want, and then I press enter to input it. X is less than or equal to 2. I close my parentheses. I put the plus to say I'm still continuing with the piecewise defined function. I open another parenthesis for the second function, x plus 1, close the parentheses, and then open another parenthesis for the interval. X is greater than 2. Again, for the inequalities, I press second math. It would be 3. Once you're done, you press enter. I hope you're seeing the buttons. Once you're done, you press enter, and you go to graph. This is my function. If you notice, it doesn't tell me which one's a 0 or a field point and which one is a whole point. Remember that our graph that was defined, let me see if I can put them both. Oh, no. Remember that our graph that was defined on the left side from negative infinity to 2 included the point, which means this line right here ends in a closed point, and the following one, the one that is defined after 2 to positive infinity, starts with an empty point. And I have it in the following slides. Here's how my function looks in my graph, and as you can see, it doesn't show me the filled point or the closed point, but if I look into this graph right here, the one from the left, defined on the left side of 2, includes the point 2, and the one defined on the right side of 2 does not include the point. Thank you.